Cool, so there's something else I want to talk about. This is a nifty little thing called isatty. Now, before I explain what that is, let me show you an example of why it's useful, okay? If we do ls, we can see we have a whole bunch of stuff here. In fact, we're done with most of the stuff. Let's move 256 colors, braces numeric, curly brace expansion, and move cursor into the done directory. There we go. So now if we list the done directory, oh boy, there's a lot of stuff here. Let me ls it and pipe it to word count minus L, which counts the number of lines there are, 25. So we have 25 files there, right? Be careful. Yes, we have 25 files, but what word count -L actually counted was the number of new lines. Remember, a file could technically contain a new line in it, and then it would throw us off here. For the most part, though, this is probably safe to rely on. But here's the interesting thing. Here's the part I want to focus on. Look at the output of ls here. Look how many lines there actually are. Here's 1 line. Here's 2 lines. Here's 3. Here's 4. Here's 5. I'm doing a bad job highlighting. 6, 7, 8, 9. There's 9 lines. So why, when we do this, do we get 25? Well, let me show you something else. Instead of piping it to word count minus L, let me just pipe it to cat. Cat reads from standard in and writes the standard out, so it's just going to flow through like there's nothing different. Now it's separated by new lines. How interesting is that? There's no color and it's separated by new lines. So what's going on here? How is ls determining this? ls is not the only program that does this, by the way. You probably use other programs that do this. Imagine if I curled, let's do this before. We curled my website, ysap.sh. Cool, it prints my website, nothing else but my website. Let me redirect this to dev null. Let's see what it's gonna print. We get a progress bar. So when the output's being redirected or sent somewhere else, it seems like we're getting a progress bar. And when the output's being redirected with ls, it seems like we get this. Close, very close. ls and curl are both detecting if your output is a terminal. That's what isatty is. It is a C standard library call. You can look it up here, isatty. You can see that it's in 3 here, so it's just a library function. It checks to see if a file descriptor is a terminal. So this is really cool, and we can do this. We have ability to do this in Bash. We have -t. -t takes a file descriptor. Remember, 0 is standard in, 1 is standard out, and 2 is standard error. We can give it 1 here, and this will check if 1 is a terminal. So let's go ahead and put this in a script because it'll be easier to understand there. Let's make a script called check terminal. And we'll do this, user bin env bash, and we'll do something like this. Let's say, chmod plus x, check terminal, vim it, there we go. If --t1, that is standard out, then echo standard out is a TTY. Okay, cool, that makes sense. Else echo standard out is not a TTY, FI. Okay, cool. Yeah, that makes perfect sense, right? So if we run check terminal, standard out is a TTY. If we pipe it to cat, standard out is not a TTY. If we pipe it to less, standard out is not a TTY. It's at the bottom now. So if you pipe it anywhere, if I grep for standard out, we get standard out is not a TTY. So if it's not outputting directly to terminal, in this case, this is outputting to cat, this is outputting to less, this is outputting to grep. Technically, they're just outputting to a pipe, and these programs are reading in from that pipe. So check terminal doesn't technically know it's going to cat. It just knows it's outputting to something and something else is reading it. In this case, it knows it's outputting directly to a terminal. If we have a file descriptor on our system, we are allowed to ask, hey, is this a TTY? Is this a terminal? So that's what's going on here. You can write code this way and you can make changes based on this. So I could do something like, oh, if the output is a terminal, then I could say, let's do the tput example, setaf1 echo, it worked. Well, 1's going to be confusing because it's red. Let's do a 2 for green. Tput sgr0. And then also down here, we could say, it worked. You could do something like this. This is a contrived example, but the reason you would do something like this is like, oh, if I'm running a program on the terminal, I get color output. That's great. If I'm writing it to a log file, log.txt, and then I check log.txt, there's no color output in there. That's good. That's probably what you want. You'd probably implement this differently. I have code where I've implemented it where I store the colors up here. I would store something like red equals, and then I would do the escape sequence for red. And then if I'm down here, I'll just close this. I'll do a full example. I don't know why I'm skimping on this. Let's do 31M like that. So we have red up here. And then otherwise we'll just say red equals an empty string. And that way, if you're down here, you could say like echo red, it worked. And then this will be set if it's going to a terminal or not. So if I run this, we can see that we get red, and if we pipe it to cat, then we don't get red. So the way I solve that, the way I use this in code typically is I check if it's a TTY for standard out, then I'll set the color codes, otherwise I'll set them to an empty string. That way I can use them down here without having to know where the output is going to. If you write code like this, please let the user override it. Curl does this, ls does this. Let the user give flags to recreate that behavior. So you see how ls works like this? I can give it ls -1 to separate it by new lines. I could also pipe it somewhere to separate it by new lines. Give the user the ability to force one way or the other. ls actually does this. The GNU variant of ls is really good. We have color equals auto. This will auto detect whether color should be used based on if the output is a TTY. They also have always, which will always make color show up even if you pipe it through cat. And then we have color equals, I think it's never. There we go. So never will there be color. So this is my advice to you if you're writing programs and you want to make a decision based on if they're outputting to a terminal or not. That's all well and good to set up some sort of sane defaults, but please let the caller of the program override these and set whatever they want. If they don't give you arguments, fine, you can do whatever you think makes sense. But if they give you an argument saying, I never want color, don't give them color output. That's my plea to you from one programmer to another who's seen a bunch of programs out there that just don't seem to behave very nicely.